Assalamualaikum and good evening. My name is Fitri with my lab partner Rajheswaran from Beea S1/2. Today we would like to do the lab assessment for lab 4. So let me construct the circuit for the part A first. So the instrument we use in this part is function generator. The function of function generator is to generate and deliver standard waveform, typically sine and square wave, to devise the test. It can be used to test, design and confirm that piece of electronic equipment is working as intended. So the second one, we use the oscilloscope. The function of oscilloscope is to test and display voltage signal as waveform, visual of variation of voltage over time. So first we connect the wire, and then put the source, and then we can put the ground. For the first one, we need to find for the period for 2k Hz. So must change the first 2k Hz, amplitude 3 for part A. So now we can run, and then don't forget to change the coupling to AC. Okay, now we can adjust the scale here. Okay, stop. To measure the period, so we can use the formula that I have given. T equal to D multiplied with horizontal setting. So basically D is the numbers of grid at the oscilloscope, and then the horizontal setting is we can refer to the time-based scale. So basically we can just use one wave to measure. So I choose channel A. For D, we can use the cursor to find the full cycle waveform. So we move the cursor. So for this wave, we get 2.5 grid. So okay, so we just apply the formula. So 200 microsecond per diff multiply with 2.5. So we can get the answer for the period 2k Hz is 500 microsecond. So for the next, for the 10 kilohertz, we just change the frequency to 10 kilohertz and then play. We can change, we can adjust the scale here. Okay, so the same method, 50 microsecond diff multiply with 2, so we get 100 microsecond. And next for the 50 kilohertz, so we apply to the formula 10 microsecond per diff multiply with 2, so we get 20 microsecond. So next, we want to determine the V peak to peak. Basically, V peak to peak is a MAC voltage change occurring during 1 cycle of AC voltage or current. So to find the V peak to peak in the oscilloscope, we can just use the cursor here, right? To the first, we must set the trace to the axis to the channel. So um, we drag the cursor, move. So we move the cursor to the maximum point. You can see here. So 41, we find the max. So we get the max 2.979, and for the second cursor, we move to the maximum. Okay, so we find the maximum. So we get 5.945 equal to 6. So the P peak to peak is 6.
Very good morning to my lab instructor. My name is Rajheswaran, son of Nadaraja, and my metric number will be B082110420. And today I'm going to do the lab assessment for lab 4 ECF, and we have to, and I'm here to do the part A, measuring the phase angle difference. And this is our setting and our circuit. For the setting, signal generator, the amplitude will be adjusted later and the frequency will be 2 kHz. And for the oscilloscope, coupling will be AC, time base and vertical amplitude will be auto set. And this is our circuit: signal generator, capacitor connected to a resistor, and all these things will be connected to the oscilloscope to see the waveform. And same goes to our RL circuit. We just have to replace the capacitor with an inductor, and settings will be still the same. So now let's have a look at our circuit. And for the RL, this is our RL circuit and RC circuit, and this will be our function generator, and this will be our oscilloscope. And for the function generator, setting will be 2 kHz frequency, and amplitude will be 3 Vp, and the waveform will be sine wave. Same goes to our RC circuit. Sine wave frequency will be 2 kHz and amplitude will be 3 Vp. So let's measure the RL circuit first. So channel 1 will be at the rising point, and channel 2 will be at the rising point too. So this is the measurement for our RL circuit inductor, and for the RC circuit the setting will be still the same, frequency 3 kHz and 3 Vp. And then you have to drag the both channel the to the zero section point, and we can conclude that the input leads the output. And then same goes to our RL circuit. We can conclude that channel A like the channel B. For the measurement of multisim, this is for the RL and this is for the RC. So the RC input leads the output, and the RL channel A likes the channel B. And that's all from me. Thank you.